Hello, it's Keith here, and today we're going to be looking at how to create a Hello World example on the Atari Lynx. The Atari Lynx, of course, the handheld system, and unlike most systems, it actually uses a bitmap-based display, and so this is going to make things maybe a little bit more tricky for us because we've got no built-in font to work with. Anyway, let's have a look at the source code and see today's example in action. So I'll just start my Lynx emulator here. Now I get a brief warning here saying my cartridge isn't encrypted. I'll explain that in just a moment. And then you can see here we've got a hello world message on our bitmap screen here. So that's very good. Let's move this out of the way. We'll have a look at the code. Now unfortunately the code is a little bit long, and that's because I say we've got this bitmap screen and we're really having to do everything ourselves. We've got no firmware particularly helping us out here. So at the very start here we've got our origin here and we've got a header for the cartridge. We don't really need to change this, we can just leave it as it is. And then I'm defining some zero-page entries that are simulating the Z80 registers because we're going to have to do quite a bit of maths, unfortunately. We're also defining an X and a Y position, and that's going to be the next virtual cursor for when we're drawing characters to the screen. We need to know where the last one was. And then we're going to set up our screen. Now, I do have to point out at this stage, what we're looking at today hasn't been tested on real hardware. It's possible that I might need to add a few extra commands if this was going to be run on a real system. I'm only running on an emulator here, so if I find out that there's more commands needed, I'll be adding them to the source code on the website. So if you want to be sure, please download the latest source code. So what I'm doing here is I'm enabling the screen memory. Now we need to specify a memory address in RAM. I'm using C000 here, and I'm using the STZ command to store 0 bytes to FD94. Now it's very important when we write to these pairs within the registers of the hardware that we write the low byte first, because if we write the low byte it will zero the high byte. The intention, I think, is if you only need to set one, you can just set the low byte and the high byte will automatically be reset. But if we want to set both and we do it wrong, we're going to be clearing our own settings. So that's setting the screen address to C000, and then we need to define some colors so we can actually see what's going on. So I'm defining the background as black here. I'm using the STZ command to write a 0 here again, and I'm setting the background to 0 green and partial blue here to give it a darkish blue. And that's the background. And then I'm setting the foreground color here, color 15, and I'm setting that to yellow here. That's our background, our foreground color. Now, when it comes to printing characters to the screen, we've got our hello world code here, but this print string routine is entirely reliant on this print character routine. And you can see it's rather long. Unfortunate, isn't it? Now, the font itself is included just here. This is a 1-bit per pixel font. Now, if you think about it, the Atari Lynx is a 16-color screen, so that's got to be a 4-bit per pixel screen. So we're going to convert our 1-bit per pixel font to our 4-bit per pixel screen, and that's why the code's going to get a little bit tricky in places. It's not too bad, so let's have a look at it now. So the first thing we're doing in our print character is we're subtracting 32. Our bitmap font has no characters below space, so we're just doing that. And then we're calculating the position within our font that the character that we want to show is. Now, each character in the font is 8 lines. Each line is just 1 byte. So we just effectively multiply our character number by 8. We do that by bit shifting here. So we're just bit shifting along here. And then we add the source address of our bitmap font. And this now has the 0-page pair ZH and ZL as the address of the character that we want to show in that bitmap font. So now we've calculated the address of the font. We now need to calculate the address of the screen. And we do that with this code here. Our formula is effectively Y position times hexadecimal 280 plus the screen base C000 plus the X position, and we're doing that just here. Now hexadecimal 280 is this in binary, and so what we're effectively doing is we're loading the Y address, we're loading the Y position of the cursor in, and then we're bit shifting it to this position and this position in the pair and adding them together, and then adding the X position. You can see that here. But we do need to multiply the X position by 4 because there are 4 bytes per character. The character's 8 pixels, 2 pixels per byte. And then we're adding the screen base here as well. So this is calculating the screen position for our character. This is calculating the memory position in our font for our character. All that's left now is to actually draw it. And that's what happens here. So we're loading in a byte from our font here, and we are then storing it into 0-page entry ZAS. We pop a bit out, we shift it into the bottom position of the first pixel in the pair, and then we shift another bit into the bottom position of the second pixel, because remember there's 2 pixels per byte. We want to make our font color 15, Now, of course, there'd be no reason we couldn't use color 1, but for consistency in my tutorials, I always use the top color within the system for the font. So we're effectively then having to double this up. So we're shifting again to the left 3 times, and we are repeatedly ORing in the first calculated value, effectively filling all of the bits with the colors that were found here and here, which were 2 bits from our original font here. Now we repeat this 4 times for the 4 bytes that make up each character width, and we then repeat for the 8 lines that make the character's height, and this will effectively draw the font for us. Of course, after each line we need to move down the screen. Each line of the screen is hexadecimal 50 wide, so we could just add hexadecimal 50, adding any carry over to the top byte here, but this will move us down a line quite easily. Now when we get to the end of our character, we move the X position along, check if we've got to the end of the screen. The screen is just 20 characters wide. If we have, we use this new line command, and you can see that, where is it? You can see that just here. All we need to do is store 0 to cursor X. We do that with the STZ command, a special 65CO2 command, and we increase the cursor Y position here. When it comes to printing our string to the screen, our hello world, we load the address of the hello world into ZH and ZL. The string is 255 terminated, and we use this print string routine here. Now this uses Y as a counter, reads in characters from ZH and L, and then it just uses print char to print them to the screen, and of course print chars are all of this monstrosity that we just saw. Okay, so that's how we can print characters to our bitmap screen here. Now, of course, it's not just a question of the source code. We actually need to create a binary file for today's example. And as I've already said, we're not creating an encrypted file. This is only good for emulators. It wouldn't actually work for a real cartridge. They have to be encrypted. But then our emulator wouldn't be able to run them without a BIOS file, which we can't redistribute, so it's a bit of a pain. Anyway, this is the source that I'm using today. Now I use these batch files to build. I'm specifying the assembly file, the helloworld.asm, just here. We're using Vasm old style here to compile. You can see this switch CO2 here. This is specifying that we want to be able to use the extra functions of the 65CO2. I'm defining a check labels command here. This tells Vasm to check if any of our labels look suspiciously like commands. Now, a common mistake you will make is you may forget your tabs in the early days and do something like that. That's going to be treated as a label, and that's probably not what you want to do. So by specifying this check labels command, it forces Vasm to make sure that we've not done that and warn us if we have. I'm disabling case sensitivity. I find things easier that way. We're defining a symbol Vasm. This is in case I want to compile with 2 different assemblers. I always define a symbol with the name of the current assembler. This helps me out sometimes. We're outputting a listing file. Listing files will show the source ASM file and the output bytecode, and they do help out if you're having real trouble. Sometimes your code might be confusing the assembler. The second pass, for example, will calculate the label values, and sometimes they may have gone wrong if you've done something particularly odd. So I have found they've helped me out quite a few times, so they're worth having. I'm defining a Lynx symbol here, which is used by the monitor in some cases, but you don't need that for the basic Hello World example. Finally, I'm specifying I'm outputting a binary file, and the name of the file is cart.o, and the O file is an object file, which is what the emulator needs to know that it's an unencrypted file. Okay, so that's built our file, and then all we need to do is specify handy, the emulator I'm using, and the name of the cartridge with the .o extension, and it will start up and run the cartridge as you've seen. So there we go. Now, we looked at the basic Hello World example, but I do have a slightly more advanced example that I always show in these tutorials. Now, when I start programming a new system, my first stage is to try and get a Hello World message on the screen. And then once I've got a Hello World message on the screen, I try and dump the registers and pieces of the memory, because if you can see what the registers are doing, you can see what the memory is doing, then you can start debugging and developing your program, even if you've just started out with the system. So that's what I really try and do. So I thought I'd make these tools available to you. We've got a monitor tool, which will show all the registers, and a memory dump tool. We specify the address of the memory, hexadecimal 3000 in this case, and a number of lines. I'm outputting 3 lines, and then we can just run this and we'll see those lines to the screen. Now, we've seen the Hello World example there, but as part of these tutorials, I always like to give a second example, which is a bit more advanced, and this provides my monitor tools that I created as part of my learning of this system. You see, whenever I learn a new system, my first challenge is to get Hello World on the screen, and then I try and get the monitor tools, which will allow me to see the state of the registers and also to see the memory onto the screen. And so that's what I'm giving you here today. And we just have these two commands here, monitor to show the registers, and memdump, which will dump a memory address, in this case hexadecimal 3000, and a number of lines, in this case 3, to the screen. And we'll just fire that up now and we'll see it in action. And unfortunately it doesn't quite fit so well on the old Lynx, but it does work. So you can see here we've got the accumulator, the X register, the Y register, the stack here, the flags, and also the program counter, of course, and hexadecimal 3000 has no bytes in it. But of course we could change that. We could change that to 400, for example, and run it again. And now you can see we've definitely got some code there, so that does work. So there we go. We're not going to go into the details of how that code works. It's from my main series, and I just wanted to make it available to you to try and help you out if you're just getting started with this system. So we've had a look at the links there. We've gone briefly into the code of how we can get characters to the screen. If you want to see all of this in more detail, I've already covered this system in my platform-specific series. If you want to know other things about the Lynx, the sound, the joystick, then they are also all covered there. But we're going to be covering them a bit further in this simple series. So if you like this kind of content, please like and subscribe. Now, of course, all of the source code you've seen today is available from my website. You can download the tutorials, and you can also download the batch files and the programs I've used in today's example. So that should help you out if you are getting started. Please take a look around my website and my YouTube channel. There's a playlist for the Atari Lynx on the YouTube channel, and there's a page on the website. So hopefully there's lots of content that you should find interesting. Anyway, I hope you enjoy programming the Atari Lynx. I hope you have fun in programming in general. Thanks for watching today, and goodbye.